All right, lovelies. I hope all of you had a great day today. It is unfortunate that we missed class due to the senior meetings this morning. However, I hope that you all found it useful and that you really feel enriched after leaving that session and being able to talk with folks in the industry. What you missed in today's class is that we finished up Unit 3, Lesson 5, and because we have a strict timeline and we're going on break next week, it is important that you guys finish this lesson on your own and that you come into class tomorrow with it completed, and we're going to go over any questions that you have. Please take the time to listen through this video. Please do not click skip or speed it up. I'm going to just do a quick review of what we did the last time that we saw each other, as well as go over what it is that you should have completed in class today. All right, so we first already talked about the change of base formula, and we know that we use a change of base formula anytime that we have a base that is other than 10. And the change of base formula allows us to rewrite any log in terms of any base whatsoever. So you already have all of this down on your paper. I'm going to zoom in here to question 2, where we spent some time. And we initially wanted to condense this log, but we noticed that in here we have 2 different bases. In here we have 2 different bases. We have base 2, and base 4. So we're able to initially condense the logs with base 2. However, because base 4 is different, we had to leave it alone. We then used our change of base formula, which tells us that we divide the log of the argument divided by the log of the base. And in this case, since I already have a log in base 2, it's beneficial for me to write my new logs in terms of base 2. So my argument is h, so I have log h with a base of 2, and I have log 4 with a base of 2. I could have also written it as such, where it was just log h over log 4, and if you do it like this, then when you plug it into your calculator will automatically assume that it is base 10. All right, so I just wanted to zoom in on that there. Your homework that was due today was for you all to finish the questions on the bottom of this page. So these are the solutions that you have. Please make sure that you don't have any rounding errors, because that is mostly what trips students up. In addition to telling me the solutions, you need to have the change of base formula version of the log written down as well. I'm going to scroll up and show you the solutions that you should have for the next page. My apologies that mine is a little out of sync, but please go ahead and check your work. Again, let me emphasize, I don't care about the solutions. I do care about the work shown. So please do not just have final answers on your paper. You need to go back, if that is the case, and show me the change of base formula for each and every single one of these questions. In my other section, a question that came up was, Miss Johnson, when I'm rewriting the log for question 4, can I just rewrite it as is? And students had many different versions, so I want to show you a couple of versions that students have, and all of them will lead you to the same answer of 449 thousandths, or 0.449. So initially, when I had done this, I had log root 5 over log 6. Another student in the class had log 5 to the half over log 6. These are equivalent statements. What the student did was just take that root 5 and rewrite it in terms of exponential form. The last option that came up or was mentioned in the other class was 1/2 log 5 over log 6. And of course, we know that this is also appropriate because of our power rule of logs. So all of these 3 versions will get you the same solution of 449 thousandths. So I just wanted to take a moment to zoom in on that. All right, go ahead, check your answers one more time. Let me leave the screen so that way you guys can do what you're doing. All right, down below, putting it all together. So these are the two solutions that you should have. Well, you should really have three, but I'm going to take a moment to go over question 2 because I do know that gave quite a bit of us a headache trying to figure it out. So for question 2, it follows the same principles of the do now question that we have on the front cover, in which I rewrote both of the logs in terms of base 2. So yes, you could have just jumped to the shortcut and said, all right, I just opted to rewrite the logs in terms of any base, and instead of using base 10 here, we use base 3. And so you have the log of the argument being divided by the log of the base. However, something that I do want to highlight was in my other section, I definitely handed out extra credit for this because the students proved why the change of base formula works, and I want to take the time to show that to you. All right, so here we are. Zooming in here, I have log base 3, argument 16, divided by log base 3, argument 21. We are going to use the change of base formula within the change of base formula. So I'm going to rewrite the numerator using the change of base formula. And I know it's the log of my argument, which is 16, divided by the log of my base. Log of our argument, 16, divided by the log of our base. And then we're going to put back our division, our fraction line. And I'm going to rewrite the denominator using our change of base formula. So the log of my argument, which is 21, divided by the log of my base, which is 3. In the numerator, we have a fraction. In the denominator, we have a fraction. And that red fraction line that's in the center tells me that I need to divide. If you are someone who does not like to see division of fractions written vertically, you can go ahead and write the same exact statement horizontally. So log 16 divided by log 3, divided by log 16, 21 over log 3. Now, this is the basic stuff. If you're stuck here, you do need to go back to Unit 1, in which we talked about how do we add, subtract, multiply, and divide fractions. Really quickly, it's keep, change, flip. So I'm going to keep the first fraction the same, log 16 over log 3. I'm going to change my operation from division to multiplication. And then I'm going to reciprocate, aka flip my second fraction. So I have log 3 over log 21. At this point, I can start to one out some of the terms. If I have log 3 in my numerator and log 3 in my denominator and the operation is multiplication, these go ahead and one out. When they one out, we are left with log 16 over log 21. And you know that using your change of base formula, I can rewrite this. I know what my argument is, and I know what my base is. My argument is in my numerator, my base is in the denominator. So all of this equates to log base 21, argument 16. So if you were listening intently at the beginning of this whole proving why the change of base formula works, you would have heard me say, do I need to go through all of this work? No, you don't, because again, the change of base formula allows you to rewrite any log in terms of any base. I just wanted to walk you through why it worked. All right, what I am tasking you guys with now, I need you to try question 4 on your own. I've done you a solid and I've given you the solution. You should have x equals negative 0.2. I also need you to try questions 5, 6, and 7 on your own. Also did you a solid there. I've given you the final answers. Please remember, I don't care about the answers. What I do care about are the steps that you've taken to solve. If you feel stuck with questions 5 and 6, you will need to go back to Unit 3, Lesson 3 to help you. It will be the 1, 2, 3, the 4th page in Unit 3, Lesson 3 that will help you be successful with completing these questions. And in case you're not sure what I'm talking about, the top of that paper says don't solve, just think. Convert 2 times 4 to the x equals 20 to log form. So you're going to use that to help you answer these questions. These are being graded for completion. You must have a valid attempt at these questions. All right. After we went over these in class, or we completed these in class, we then went on to here. And here is where I really need y'all to lock in. I'm going to walk you through the process of solving these questions. You'll notice that there's a dark line down the middle of the page that is there on purpose. Why? Because there's multiple pathways to solving, and I want to show you both so I know that you have access to both. Pause the video here and follow the steps that I've given you on this paper and attempt it. When you're doing your attempt, please use a pencil just in case you make a mistake. So pause the video here and try it. All right, now that you've made your valid attempts, or if you didn't, we are going to follow the steps. So step 1 tells me that I need to convert my question into log form. I was given an exponent, I was given the equation in exponential form, and my variable is in the exponent. So I need to convert to log form in order to be able to access that, to access those variables. So in order for me to do this, please only write on one side of your paper. I'm going to do the first pathway. I'm going to choose to rewrite my log in terms of base 7. So I'm going to write log base 7. My argument is the entire right side of the equation. So I'm going to have the argument of 3 to the 4 to the x power, 4 times x power, equals x plus 5, which is the exponent of my base 7. The next step tells me use my power rule. My power rule tells me that if I have an argument being raised to a power, I can go ahead and bring that down in front of my log. So I'm going to take this power here and I'm going to bring it down in front of my log, and I'm going to have log, or 4x, times log base 7 argument 3 equals x plus 5. That's our step 2. Step 3 tells me to gather all of my algebraic terms on one side, aka get all your variables to one side of the equation. In order for me to do that, some of you may say, all right, let me divide both sides by 4x. I can fully understand why you'd want to do that. However, what will end up happening is we're going to get an unfriendly fraction. And so, because of that, I'm going to opt to subtract x on both sides. I need to do that in order to accomplish my goal of being able to do step 4. No, you cannot subtract x from 4x because the operation here happening between the 4x and the log is multiplication. And if we were to do that, we would violate PEMDAS, which is what you guys learned from elementary school, which is your order of operations. So what I'm going to do is write this back exactly the same way I see it. Also, if you don't want the multiplication dot there, you don't have to have it there. You could just write this as 4x log base 7 3 minus x equals 5. Step 4 tells me, all right, I need to factor out an x. Since both of the terms that are on the left side of the equation share an x, I can pull that out, aka factor that out. If I factor out x, I need to open a parentheses. Remember, factoring is the inverse of the distributive property. And I'm going to be left with 4 log base 7, argument 3, minus 1. And I'm going to close this parentheses. I'm going to set this equal to 5. Some folks might wonder, well, Miss Johnson, how did you get this 1 here? If I were to do the reverse and distribute this x times 1 would give me that negative x that I have right here. And if I do 4 log base 7 argument 3 times x, I would get the statement that's up above right here. All right. Now the last step I need to do is isolate x. The operation that is happening between x and this parentheses is multiplication. So the inverse is division. I need to divide both sides by everything that's in that parentheses. So 4 log base 7, 3 minus 1. And so now my equation is x equals 5 divided by 4 log base 7, 3 minus 1. I need to type this into my calculator. What's our dilemma? If you said our dilemma is that we have base 7 and not base 10, then you are correct. What we need to do is use the change of base formula in order to type this into our calculators correctly. So if I'm and I'm going to rewrite this the same way that you should be typing this into your calculator, and in a moment I will show you how to do it on screen as well. I will need to rewrite, first of all, the log using the change of base formula. So 5 is in my numerator, over 4 is a coefficient. My change of base formula tells me I'm going to do times, log base 3 over log base 7. And since it's a fraction, I'm going to put it in parentheses. And then I'm going to subtract 1. No, you cannot do 3 minus 1 and then change the argument to be 2. Again, that would be violating your order of operations. So you need to compute the entire log and then subtract 1. Because I'm working with a fraction, I'm typing fraction into my calculator, I also need to put the entire denominator in parentheses. Give me a second to show you the correct way to type this in as well. Let me pull up this. Here we go. So I have 5 divided by, and when I open a parentheses, 4. Open another parentheses so I can type in my log. And when you type in log, it automatically opens up a parentheses for you. So I'm going to type in 3, and I have to remember to close that because 3 is the argument of this particular log. Divided by log 7. Again, close this parentheses because that's establishing that 7 is my argument. And I'm going to close this other parentheses because I just told my calculator, all right, all of that is just the log that I need you to divide first. Then I'm going to subtract 1, and then I'm going to close this parentheses as well. So I just put the entire denominator in parentheses. I'm going to hit enter, and this is my solution. According to the question on your paper, it wants us to round to the nearest thousands. So I'm just going to go ahead and write down all the values and do a quick rounding tutorial with you. 973614765. Cool. I first need to identify what number is in my thousands place. So if I am doing this, do I have a pointer? No. This is my tens. this is my hundreds, this is my thousands. So the 3, I'm going to highlight it, is in the thousands place. Behind the 3 is a 6. This 6 tells the 3 to go up or round up to the next value. So when I am done, my solution will be x equals 3.97, and now the 6 told that 3, it needs to become a 4. So this is my solution, rounded to the nearest thousands. All right, so I'm going to zoom out so that way you guys have all of this information. Again, please make sure that you are actually listening to me explain this stuff to you. What I don't want is for you to just pause the video, write everything down, and then come to class and have no idea of what's happening. All right, with that being said, this is the first pathway that you can take to solving. Now, we're going to have a look at the second pathway that you can take to solving. So let me make this full screen again. Zoom out just a little bit. So this first round, or this side in blue, I rewrote the log in terms of base 7. That was not my other option, all of my options, sorry. I could have opted to rewrite this log in terms of base 3. So log base 3, my argument would be what? If you said 7 to the x plus 5, you are correct, equals 4x. For those of us that are stumped, here you go. Now, according to my steps, I did the first one. I converted to log form. Now, I need to use the power rule. So again, the power rule tells me, all right, if I have an exponent, it comes down in front of the log. So I can rewrite this as x plus 5 log base 3, 7, equals 4x. If you have this on your paper, you're great, or if you intuitively said that, you are great. One thing I do want to point out to you, though, is since my exponent has multiple terms in it, I will need to place this x plus 5 inside a set of parentheses. And if you want to make it mimic the other side, I could put that multiplication symbol in there. I don't have to. But again, I'm going to stress for you, since the exponent has 2 terms in there, once you have multiple terms and you're using the power to power rule and you're bringing the exponent in front of your log, it must go inside a set of parentheses. So we did step 2. Now I need to gather all of my algebraic terms on one side. But before I do that, I have to make a check. I'm scanning my log and I see that I have a term sitting immediately out front of my log. And like we said in the previous side, no, I don't want to divide both sides by x plus 5 because it's just going to make it unfriendly for me. So if I have a term immediately in front of a set of parentheses, you should be triggered to want to distribute. And so that's what we're going to do. We're going to distribute log base 3, 7 to both terms inside this parentheses. Typically, you're accustomed to seeing what you're distributing in front of the parentheses. It doesn't have to be there. It could be in the back as well. And when I do this distribution, I'm going to have x times log base 3, 7 plus x times, or excuse me, plus 5 times log base 3, 7 equals 4x. So Ms. Johnson, why would I want to expand that? Why does that make it easier for me? Well, you're about to see now. I want to put all the algebraic terms on one side, aka get everything with an x on it to the same side of the equation. I could do a couple different things. I can subtract 4x on both sides and get it equal to 0. I could subtract 5 log base 3, 7 to both sides. I could subtract x log base 3, 7 to both sides. What is the shortest pathway of those three options to getting all of my x's on one side? If you said subtract x log base 3, 7 to both sides, you are correct. And again, this is just basic algebra. In order for me to move a term from one side of my equation to the other side, I need to subtract. Don't let the fact that the word log or that there's words in the math that you're doing trip you up. It's still the same stuff. On the left side of my equation, we're left with 5 log base 3, 7 equals 4x minus x log base 3, 7. Cool. We've just finished step 3. We got all of our terms to one side. The next thing we need to do is factor out x. So, since I have all the algebraic terms on one side of my equation, now I can factor. Again, remember that factoring is the inverse of distribution. So when I factor out x, what are we left with if I take x away from both of these terms? Go ahead and write that down on your paper. If I factor out x, we're left with 5 log base 3, 7 equals, I'm going to have x in a parentheses out front. In my parentheses, if I remove x from the 4, I'm going to have 4 left. If I remove x from the log, I'm going to have log base 3, 7. Now the last thing to do is to isolate our x. In order for me to isolate x, I need to use inverse operations. At this moment, I have x being multiplied by all of the terms inside the parentheses. The inverse of multiplication is division. So I'm going to divide both sides by 4 minus log base 3, 7. Cool. So if you got this far and you're following with me, we're in a good spot. But again, I'm being asked to round my solution to the nearest thousands. So I can't leave it like this. I actually do need to put this into my calculator. So let's go ahead and rewrite this in the form in which we could type this into the calculator. This time around, we have the same dilemma. We don't have a base 10, so we do need to use our change of base formula. I'm going to keep my coefficient in my numerator, and my numerator becomes 5 times my change of base, so log 7 divided by log 3. I'm going to close that parentheses all over 4 minus log 7 divided by log 3. If you are someone who says, oh, the log 7 over log 3 should 1 out, it doesn't. If you were to 1 out log 7 over 3 in the numerator and the denominator, again, you'd be violating your order of operations, mainly because there's a subtraction sign that is happening in the denominator. The only time in which you can 1 terms out from the denominator and the numerator is if the operation is multiplication. So last thing to note is that because there is so much going on in my numerator and my denominator, I need to let the calculator know, hey, I need you to calculate the value of my numerator, then I need you to calculate the value of my denominator, and then I need you to divide the two. In order for us to do that, we need to put parentheses around our numerator, and then another set of parentheses around our denominator. And this is how we should enter it into the calculator. All right, let me pull up the calculator again. And so we can do this together. So for this one, I am going to zoom us in and type this in exactly the same way we see it. So we first open up a parentheses for our numerator. We're going to type 5. We're going to open up another parentheses, and we're going to do log 7. I need to close this parentheses because I'm telling the calculator 7 is my argument. I'm going to divide by log 3. Remember to close your argument parentheses. And I just told the calculator, all right, that's my fraction. So I'm going to close this parentheses again. And I'm going to close the last one. For every open parentheses, you have to have a closing parentheses. So this in my calculator looks exactly like what we wrote on our paper for our numerator. Then I'm going to divide that. Open another set of parentheses. I'm going to have 4 minus. Since I'm working with a fraction, I need to open a parentheses. Log 7, closing my argument, divided by log 3, closing my argument. Close the fraction. And now close my denominator. When I hit enter, you'll notice that we have the same solution as we did for the previous question that we typed into our calculator. So same deal, when I'm rounding, I am going to get x equals 3.974. All right. So zooming out so that way you guys can see everything. Tomorrow, come to class with all of your questions. What you are responsible for doing is completing the rest of this lesson on your own, and then we will have the time to preview and talk about things. Please note that if you haven't done this work before you get to class, we will not have those conversations. So, just a recap. If you haven't finished these questions on the second page, which was due today, but it wasn't checked because of your senior workshop this morning, then you need to do this. I'm asking you to attempt these problems, and yes, I purposely did not make a video for it. However, I did give you the solutions. I also have told you which set of notes to look back in case you are stumped. So in case you need help, question 4 walks you through step by step what you should do. For 5, 6, and 7, use Unit 3, Lesson 3 to help you. You've taken these notes already, and I need you to complete these 2 questions before class tomorrow. These 2 questions mimic what we have just gone over in these notes. So one time, when you come to class tomorrow, everything will be done, and come with your questions. I need to see a written, valid attempt from absolutely everyone. Even if you don't have it 100% correct, that is fine. I need to see what you can do so that way I know how to troubleshoot and where best to spend our time in class tomorrow. All right, y'all. Have a good evening. Bye.